Yeah, welcome to my channel. In this video, I'm going to explain digital signature. Uh, First, I'll give a definition of digital signature. So, digital signature is a cryptographic value, right? Digital signature is a cryptographic value. This cryptographic value is generated. This cryptographic value is generated from the message or data. Generally, this message or data, which is finalized by the sender, you want to convey this particular information to receiver, right? So this cryptographic value is generated from data with the help of key. With the help of key, this key must be known to only sender, right? This key must be known to only sender because sender is doing digital signature on the message, right? So that's why this key must be known to only sender, and whatever the sender wants to send the message, that is called as original message. He must generate this particular signature or data, right? So this particular data is going to be encrypted with the help of key. That's why once the data generated from the message is encrypted by sender's secret key, because that key is known to sender only, sender's secret key, then we call it as a signature. Then we call it as a signature because the signature is generated from the message, and that particular message is encrypted by the sender's secret key. Then only if sender uses his own secret key, then only that encrypted data is treated as signature, right? So the key which is used for generating key is known to only sender, right? So that's why this digital signature is coming under public key cryptography. Public key cryptography. So this public key cryptography environment, this digital signature involved sharing the message in secured manner between sender and receiver. Then why this particular digital signature is introduced? Just for three reasons, very important three reasons. This digital signature is used. One is authentication, very important. One is authentication. I told you already in previous sentences, because sender generates the signature by using his own private key. So sender is using private key at the sender side. Then that particular authorized details are verified at the receiver side using this signature, right? Again, receiver side, receiver generates the signature using the same procedure which is used by the sender, and this particular signature and received signature. Generally, along with message, the sender also sends the signature. At the receiver end, receiver also generates signature from the message, received message, and he compares generated signature and the received signature, right? This is generated signature, this is received signature. If both are same, if both are same, then receiver feels that sender is authorized. That is called as authentication, right? So authentication is verified by digital signature. Second one is non-repudiation. Non-repudiation. Repudiation means denial, right? Non-repudiation. This is another service. See, this non-repudiation means once sender and receiver mutually agreed each other for communication, mutually agreed each other for communication or contract. If they made a contract between themselves or between them for making communication, then they should not break the contract. They should not break the communication. Okay, na? So no sender should, the sender should not deny the sending messages. Receiver should not deny receiving the messages, right? So that is happened through digital signature, right? And third one is integrity. Because I told you already, at the receiver end, receiver generates the signature from the message, right? Receiver generates signature from the message. So that signature and the received signature, right? Received signature are compared. Generated signature at the receiver side. If this is the received signature, right? So received signature and generated signature at the receiver side are mapped, compared each other. If both are matched, then we say that there is no integrity happened. Means there is no updation happened on the message, right? So that's why for these important three reasons, digital signature is developed: authentication, non-repudiation, and integrity. Now I'll show you different configurations which are used by the sender and receiver for utilizing this digital signature concept for sharing the messages, right? I will start with the basic structure, very basic structure, and after that I will tell you what are the updated versions of this particular basic structure, right? Once you understand basic structure, you can only easily, because we already seen these configurations in public key cryptographic environment. 3 configurations, right? So here also I'm going to show you 3 configurations for implementing digital signature. One is very simple. One is very simple because this is the message sender wants to send. This is the message, or we can simply call it as data, right? Message or data sender wants to share, right? Now, what sender do here is he sends this particular message as input to hash function. Message as input to hash function. So generally hash functions and mac functions are many to one functions, right? Many to one, because the view size information is received by the hash function, which produces fixed size length hash value or hash code. We call it as hash code or hash value, or we simply call it as hash value, or cryptographic value. We call it as cryptographic value. So after generating hash code or hash value from the hash function, this hash code or hash value must be processed to digital signature generation algorithm, right? So digital signature generation algorithm. So generally for generating signature, sender must use his own private key, right? Sender must use his own private key. Then only we say that this is the output of this is signature, right? So this signature and the original message or concatenated each other at sender side. This is the finalized message at sender side, right? So one is the message, here plain text message is transmitted, and another one is hash value is generated from message by inputting that message to hash function. This hash value or hash code or encrypted value or cryptographic value. This cryptographic value undergo digital signature algorithm process. This digital signature algorithm, generation algorithm using private key of sender. Then only we call it as signature, right? Then only we call it as signature. So that signature and message are concatenated to each other. That information is transmitted to receiver, right? So this portion is sender to up to concatenation is sender. Up to concatenation is sender portion. So this is receiver portion. Receiver receives message as well as signature, right? Message as well as signature. Then receiver must verify whether sender is authorized or not and the message is not updated. How? First, you must verify the signature. So digital signature generation algorithm is used by sender. Then signature verification algorithm is used by receiver. Digital signature or signature verification algorithm, right? VA means verification algorithm. I'm writing in shorter form, right? You have to write while writing exam, you have to write it in full form, right? This is digital signature generation algorithm. This is signature verification algorithm. So generally signature verification algorithm is used by the receiver, right? So signature generation algorithm using receiver's senders for private key. So that's why the receiver must use senders public key. Receiver must use senders public key. Then only this particular hash code is restored from encrypted one, right? So here hash value is generated. Hash value is restored by using verification algorithm. But this hash value must be compared by receiver, right? How? Again, you must generate hash value from the message as the sender generated hash value, right? You must first give hash function, whatever the hash function that is used by the sender, the same hash function you must use. You must give message as input to hash function. This hash function generates hash value, right? The same procedure. Here, sender used this procedure, right? The same steps the receiver uses to generate hash value. So this hash value and the received hash value are compared each other, right? The generated hash value and received hash value are compared each other. After comparison result, then receiver feels that whether sender is authorized or not, and message is updated or integrated or not. This is the receiver portion, right? If hash values are both same, then receiver feels that the message received is correct. And he used the sender's public key, right? Then sender used his own private key. Then sender is also authorized. So from this particular comparison operation, he gets two important informations. One is sender is authorized. Second one is not message is not updated by the opponent or criminal or attacker, right? So this is the first scenario. But in this scenario, plain text message is transmitted as easily as plain text only. But at the receiver, it is very easily modifiable, right? Yeah, opponent can easily modify this because sender is sending plain text. But even opponent updates this message, receiver can easily identify by using verification procedure, right? He generates hash value from the message, received message. He restores hash value from the received hash value encrypted form, and he compares those two values. If both are same, receiver feels that updation is not happened, which integrity is not happened, and the sender is authorized sender because sender's public key is used for restoring hash value, right? So this is one scenario, but here drawback here is sender is sending the plain message, plain text message, right? And I'll tell you two more methods. One method, next method is instead of generating hash value from the plain message, is sender is going to generate hash value from the encrypted message, right? Hash value from the encrypted message. I'll draw the complete diagram now. Okay, hash value is generated from encrypted message. That encrypted message is imported to hash function for generating hash value. The same procedure again. From hash function, the same procedure, right? From hash function, the procedure is same. Okay. Now I'll show you that alternate method. Okay. So this is the message or data sender wants to convey. Then initially, instead of sending this particular message directly to the hash function as input, here first he uses encryption algorithm for encrypting this message, right? Anyway, sender is using his own secret for generating signature. But distant signature algorithm is publicly cryptographic algorithm, right? Publicly cryptographic algorithm. So in publicly cryptographic algorithm, sender and receiver must use public and private keys only, right? So anyway, sender is using his own private key for generating distant signature. So that's why for encrypting purpose, sender must use receiver's public key. Receiver's public key, right? Sender must use receiver's public key for encrypting the data. Now, this particular encrypted information is undergo hash function for generating hash value. So this hash function receives encrypted message. From this hash function, we get hash value. Same story, again same story. From hash value, sender generates signature, right? So signature generation algorithm sender uses. Sender uses as previous configuration. Sender uses signature generation algorithm, but for generating signature, he must use his own private key. So sender's private key is used by the sender. Sender's private key is used by the sender for generating signature, right? So this particular signature and the encrypted message both are concatenated each other. So this is the finalized message at the sender side, right? What are what sender conducted now? Instead of using plain text for generating hash value, he used ciphertext, right? Because he immediately encrypted by using receiver's public key. So this is the ciphertext. So from the ciphertext, sender generated a hash value. This hash value is encrypted means from this hash value he generates distant signature by using his own private key, right? So this is the message finalized. One is encrypted message that is concatenated with the signature, right? So this message is received by the receiver, right? So this is sender portion, right? This portion is sender portion, sender. And at the receiver side, receiver received two messages. One is encrypted message, second one is signature. Encrypted message, second one is signature, right? So this signature is generated from encrypted message. So that's why a receiver should also generate hash value, right? He uses hash function as a sender, right? He uses hash function. From this hash function, he generates hash value, right? Okay, now. So this hash value is regenerated by the receiver from the encrypted message. Now, this hash value is compared by the received hash value, but this received hash value is generated from signature generation algorithm with the private key of sender. Now, what receiver uses? Receiver must use algorithm that is signature verification algorithm. Signature verification algorithm produces hash value, right? Produces hash value. But this hash value is generated from encrypted algorithm, encrypted message, right? Here also this hash value is generated from encrypted message, right? So these two are compared each other, but signature verification algorithm is using opposite key. That opposite key is sender's public key. Opposite key is sender's public key, right? So sender's public key is used by the receiver for generating signature. So that particular hash value, this hash value and generated hash value both are compared. If both are same, then receiver feels that message is not updated, right? So this is the second configuration, right? So receiver side, receiver conduct this operation, but he is using extra operation compared to first configuration as encryption first. We encrypt the message. From the encrypted message, sender generates the signature. That encrypted message and signature are forwarded to receiver. This is receiver end. Receiver must generate signature also from encrypted message because sender generated the signature from encrypted message, but not complete signature because signature for generating signature he used private key of sender. Sender used private key of sender, but he must use the verification algorithm for generating hash value. Then the same hash value receiver must generate, right? Because sender cannot use so receiver cannot use sender's private key for generating signature. That's why up to this hash value generation receiver uses process. But he can also receiver can also generate hash value by using signature verification algorithm. But the signature verification algorithm requiring public key of sender because sender uses his own public key for generating signature, right? In reverse, you must generate hash value by using sender's public key. So this signature verification algorithm generates hash value by accepting another input as signature public, say sender's public key, right? So after generating hash value and after generating hash value by the receiver, he immediately generates that particular generated hash value with the received hash value, right? He restores received hash value by using signature verification algorithm. If both are same, then receiver feels that the sender is authorized, okay, and that message is not updated by the opponent. So this is the second application, right? First one is simple, directly uses plain text message for generating key. Then same plain text message is concatenated with key, sorry, signature. Those two are forwarded to the receiver. Receiver also uses the same operation for generating signature. Both are compared. The hash values both are compared to each other. But in second configuration, instead of involving plain text directly, he encrypts plain text, and from the ciphertext, he generates the hash value. At the receiver end, he also generates hash value from the encrypted message. He must also restore the hash value from the received information. Both are compared at receiver end. If both are same, receiver feels that data is not updated and sender is authorized the sender, right? So this is one. The second argument. And third one is instead of encrypting the message, first he generates hash value from original message. Just he sends the information to hash function as input. This hash function generates hash value. This hash value as a first configuration, right? This hash value and the original message are concatenated each other. So this is common up to from the first configuration. This is common. So first configuration also used the same concept, but before transmitting this particular entire message by the sender, we encrypt the entire information by using encryption algorithm, right? Uses encryption algorithm here. But for encrypting this, but for the here signature must be generated, not hash value directly. Signature must be generated because the signature is very, very important. Huh? As a second configuration, after generating hash value, you must generate signature, right? To forget the step. You generate signature by using result signature generation algorithm, right? Result signature generation algorithm generates but he uses secret key, which is very, very important. Sender uses his own private key or secret key, right? So this signature and the message are concatenated each other. After concatenating message with the signature, he encrypts the message. That encrypted message is forwarded to receiver, right? So this is encrypted message. You must decrypt it, right? By using decryption algorithm. So this encrypted message is transmitted to receiver. At receiver end, you must decrypt it. From this, he restores original message as well as signature, right? He restores original message as well as signature. Okay, na? Because the message and signature are encrypted by using receiver's public key. It's the same concept as previous one. But instead of encrypting the message first before generating signature, here after generating signature and after concatenating original message with signature, data is encrypted. But the same key, receiver's public key used for encrypting. That encrypted message is received by the receiver. That encrypted message is containing original message and signature. He decrypts by using his own public key, right? His own secret key, right? His own private key, right? So after the decrypting received message with his own private key, receiver's private key, we can restore message and signature, right? But he must get the confidence that received message is correct. How we can? We must generate the hash value by using signature verification algorithm. Signature verification algorithm is used by the receiver. He verifies the signature, means he generates the hash value in reverse by using sender's public key, right? Sender's public key, because sender used his own private key for generating signature from hash value, but here receiver must restore hash value from signature. Just by using signature verification algorithm, he can restore hash value, right? He can restore hash value. So hash value is restored from the received message. And again, receiver must generate hash value from the received message, right? It is normal configuration, first configuration, or first method. So he uses hash function, receiver uses hash function, and he generates hash value, right? He generates hash value. This is similar to first configuration, right? So this hash value and generated hash value both are compared each other. So this is the alternate. If comparison result is true, means we get both are equal, then we conclude that the message is not updated by the opponent and the sender is authorized because receiver used the sender's public key successfully restored hash value. If he can restore hash value successfully, then he feels that sender is authorized because sender used private key for generating signature. Then he used the reverse process. From signature, he generated a hash value. That hash value and the hash value generated by receiver are compared each other. If both are same, receiver feels that sender is authorized and the message is not updated by the opponent. So in this way, sender and receiver uses digital signatures for sharing the messages, right? Thank you for watching this video. Thank you so much.